right? Or more fixed points, okay? They actually, the Kerr-Nishimura paper is actually about those. Okay, it's about the case in which there's more fixed point, but that, as you will see in a moment, that requires the production function to be not concave. Okay, we'll make a note of that. So, as long as it's concave, it has to be like that. And we have stability, much simpler. Not only, as you will see, the argument is completely economical. That is, it has to do with income substitution effect. And so that's the beautiful idea they had to simplify the whole thing was the following. They said, which actually Luigi eventually, and I with him, used to prove our result. If you look at that problem, for a while, you realize that the argument you maximize, that has this abstract symbol, is actually a simple concave function of two arguments. One is given x and y that you have to maximize. Because you see, u is a concave function. F is concave, so this is the concave function of f and y. And w is concave, and because it's separable, the two are strictly concave for sure. There is no, right? See what I mean? So this problem can be written in a much more simple form, like max with respect to y, u of x, y. And respect to what? Y, right, is what? Is tomorrow capital stock. And we know it's a number larger than 0 and less than f of x, where f of x is given. Sorry, I put the bar, I should. When I think that something is given, I put a bar, so that, right? That's it. Wow, this is the consumer problem. Right? In fact, write even more simply. They say, wait a second, I can write this as u of c. Right? So in this form, this is just a consumer problem with a given constraint. And I can use trivial maximization argument. But then if I look at it a bit more, I say, this is c. So I can actually rewrite this thing as max u of c plus delta wy subject to c plus y less or equal than f of x, where f of x is given. And now it is the pure consumer problem with two goods, relative price of them is 1. So if I go here, I put c here, y here, I fix f of x here and there. This is the straight line, and these are the isoquants. Right? And so if I change x, all I'm doing is simply moving the budget line out, increasing. And I know that if the two goods C and Y are normal good, as income increase, because the slope of the budget line is always 1, right? So there is no substitution effect, I will be demanding more above. So I've proved that the function is monotone. In fact, I proved the consumption is monotone in capital. The richer you are in capital stock, the more you consume. And investment is monotone in capital. The richer you are in capital stock, the more capital stock you have tomorrow. Right? It just purely follows from the fact that consumption today and consumption tomorrow are normal goods. And then in this model, the relative price does not change. This second assumption is crucial to make the proof that simple. In fact, it's crucial to make the proof. Without that assumption, the proof doesn't go through, and you can produce counterexample. Right? So the fact that in the one sector model we make this extreme assumption that we say the relative prices of consumption goods and capital goods do not change over time. do not change because you change factor endowment. They always remain the same. Is crucial in proving that the steady state, the stable state is stationary. Sorry, the stationary state is stable. The stable state is stationary. All right? I went fast. Let's try it again. You follow? You write down a dynamic programming. You look at it, you realize it's a problem with two variables. And then you actually realize it can be very much simplified and written as a consumer problem. Maximize a utility function, totally concave and standard, consumption today, happiness tomorrow. Right? And the trade-off between the two is always one, always two. It doesn't really matter that it's one, actually. It could be 72. What matters is that it doesn't change with the stock of capital. As the state of the system changes. Now, you say, why Baudrillard is saying that? Why is he saying the state of the system, the stock of capital? Because think what goes on in an accumulation problem like that. What happens as XT increases? Go back to the model. How did we define XT?
Capital divided by labor.
Capital divided by labor. And labor is evolving itself. Right? So what's going on when XT increases is not purely that we are accumulating more capital, we're actually changing factor endowment ratios. We're changing the capital labor ratio in the economy. But what we're doing is capital is becoming more abundant. Right? The economy is undergoing a structural change. For a one sector, one good model, this doesn't matter because who cares? It's always the same technology, you always produce the same good, everything goes in the same capital stock, in the same production function. The only thing that changes at most are the relative prices of capital and labor. Right? But because it's always the same good, the two factors get paid differently, but the good is the same good. There are not two good, three goods, four goods here. Okay? So that's very special. You understand? So I'm not going to teach you about this, but if you want to understand some of the stuff we did and I did at the beginning of my research on growth, was actually studying the case in which this fails. Because this is a very special result. But I think that one of the big limits of modern macroeconomics is to take the dynamics of the one sector model seriously, whereas they're very special. And I think we fail brutally there. Because think about, and I'm not going to write the equation, if you're interested I'll give you the references and you can study this and blah blah blah. You can find in some of my old papers and some of Ron Johnson, there's a lot of people pointing this out. Think about the difference between a model with, do you know a bit of international trade? Do you have an idea how in a world with two sectors, two different goods, you allocate the factors of production? The basic Escher-Ohlin structure. Before going Escher-Ohlin with two countries, you can start trying to do Escher-Ohlin with one country, right? A very elementary Escher-Ohlin story is two countries, two goods, two factors. The reason the two countries trade is because they have different endowments in the two factors, and that makes one of them having a comparative advantage in producing good one, and the other in producing good two. In the Escher-Ohlin story, which I don't like very much, I think it's completely passé, all right, but we don't have time to do that. Because technology are fixed, there is not the reason one country has a comparative advantage of producing good one is because it's more intensive in the factor that good one is more intensive, and vice versa. Okay, so you can think of the story about, you can reformulate the Ricardian example, which didn't have it, by saying, well, Portugal was more intensive in good land. All right, and labor. And good land is particularly intensive in the production function of wine. That's why they have a comparative advantage in producing wine, because they have all this good land relative to labor. England is more intensive in labor and has little good land. And because labor is the intensive factor in the production of textile, then England has an advantage. All right, that's the kind of old story. I think it was very good to understand, frankly, 18th century, 16th century, even 19th century stuff. Eventually things got, there was a lot of technological change, and that's something that model cannot handle at all. And I think it's horrible when we try to understand trading with China and globalization of using Asher-Olin. It just makes no sense, and anyhow, I'm not giving a course in international trade. It's definitely the wrong model to think of. I mean, it's good for some things, but not for, if you want to understand why the Africans get out of Africa and wants to go to a place where there are factors, that's easy, but other than that, if you want to understand German versus Italy trade, or even China versus United States, using Asher-Olin is just too enough. Point is that as a tool, before going to two countries, you can try to do Asher-Olin at home. And you can ask the question, which is actually the edgeworth box question. If I have two production functions for two goods, how do I split the factors between the two goods? Sorry, between the two production functions. Remember, you must have seen this as an undergrad. I have this quantity of labor in the aggregate, and I have this stock of capital in the aggregate. And good 1 is here, and good 2 is here, and good 1 has these isoquants, and good 2 has these isoquants. Right? And how do I split the factors? Well, I split the factors, right, by picking the point like that. And in fact, I can trace out the production possibility frontier by picking all the tangency points, right? And this is a splitting L1, L2, K1, K2, right? That's the way we do it, right? Well, what happens in this world? In this world is that if the two goods are produced with two different technologies, then which one will or will not be more capital intensive at the efficient point will depend on the aggregate capital labor ratio. In our economy, L is fixed in some sense, we can normalize it, right? And so the process accumulation means that the edgeworth box does like that. When the edgeworth box does like that, this thing may change. And so if here one sector is more capital intensive than the other, then over there, that need not be true. Or, well, I should do it like this, we can get that, right? All kind of, what does it mean? When the factor intensity between the two sectors change, it can even re-switch. So sometimes you're more capital intensive than me, but later on I am more capital intensive than you, okay? When there is this shift, the relative price of the two goods change. Right? Because think, accumulating capital means making capital more and more abundant in that economy. This is going to favor the sector that uses capital more intensively. So I may start from a situation in which I have little capital and a lot of labor. So I tend to produce the good that uses lots of labor. Maybe that's capital, because capital is more intensive in labor. Well, but that implies I'm accumulating a lot of capital. And I may accumulate capital so much that eventually I have, in fact, capital now is the abundant factor. Well, but that favors the good that is more intensive in capital. Maybe that's consumption. At that point, I switch, right? The incentive is to produce a lot of consumption. And I may exaggerate, so to speak, end up producing so much consumption that my capital stock declines. And then I start again, right? In this graph, in the graph I did before, instead of having this, there is always the same, right? In a two-sector model, and therefore in a 3, 4, what happens is the production possibility frontier may start out like that, but as you grow, it goes like that, then it goes like that, and then it goes like that. And your tangency points change, right? And so your paths are no longer monotone. Right? So that's the story. But we stop here, okay? That's off the track of what I meant to teach you. All right, so now what have we done? We've done the theory, the story, the mathematics a bit of the classical model of growth that converge to a steady state. Or converge to this simple balanced growth that we have seen may come out either from that CES, the Soros footnote 6 example, or even here, if capital keeps accumulating but keeps the same ratio with labor, right? This is a model of growth in which the economy expands because demographic expands and labor force increases. They don't increase income per capita, but they increase total capital stock. Right? They're two different stories, and the theory of economic growth tends to focus on the first, constant population or demographic. I think as a starting point it's very visible. What's important is when you try to study history and policy, not to forget that demographics do play quite a big role. And we are experiencing it. The Japanese are, the Chinese soon will, you know. The way in which demographics kick into the growth process is less fast, it's more slowly than technological change, it's more slow than investment patterns. You realize demographics it's driving you in a certain direction after 30, 40, 50 years, right? Look at the Italians, you know, people have been, or the Spanish, you know, we've been pointing out demographic issues for half a century, since the 70s in some sense. But, you know, people, even now, they're not even understanding, okay? So, obviously it's something you don't tend to pay a lot of attention, especially if you talk policy, but if you're trying to understand history, you better, okay? But again, as a starting point, it's not unreasonable to take population costs. So most of the theory of economic growth is developed after the initial work in the 40s, 50s, and even 60s, in which people did take into account some form of demographics. And after a certain demographic literature that is out there, you know, Chino and others try to work on that, most fancy growth theory takes population constant. So given that I'm teaching, I'll do the same with you, all right? So we'll start talking about growth with constant population. All right, so what is that we have seen? We have seen that, in fact, it's already clear in the aggregate model in the 50s that you can have growth in income per capita when decreasing returns to capital, two different things, are not too strong. And this is perfectly consistent with neoclassical production function and constant technology. In fact, this was nothing but a simple macro version of von Neumann. Now, have you guys read von Neumann? Because if you haven't read von Neumann, no point I. So, I can see from the faces the answer is no. So you fucking go and read von Neumann. Okay? Do me a favor and we'll talk about that Tuesday. All right? You study von Neumann and then you actually, what is that I gave you? The Koopman's thing, because he gives a simplified example of von Neumann, 2 by 2, which I think should help, all right? Von Neumann is very simple at the end to understand if you understand matrix algebra, okay? He uses a fixed point theorem, but it's a simple thing, and all he proves is basically that a generalized linear economy with a fantasticillion goods and a fantasticillion industries and firms has a balanced growth path. That is, it can grow forever, expanding at a constant rate and holding the ratio among goods, both output goods and input goods, constant, balanced growth. The thing I described to you Tuesday is there proved. Why is it relevant theoretically? It's relevant theoretically because if you, apart from reading von Neumann, you also read Schumpeter, you understand why Schumpeter is so crucial. Because Schumpeter, if you read it, and it's really easy, and you should, it's all extremely well written and very intelligent. You want to become an intellectual, you better learn from those that were for real and for sure. He says, look around. We're all talking about growth and saving and investment and blah, blah, blah. Like that is the source of why we're becoming richer. He says, but that's a truckload of bullshit. Just use your brain. He says, think about what a stationary economy with no technological innovation whatsoever would be in reality. And then he's careful and precise as a good theorist, even if he doesn't use math. From an economic point of view, if there is no technological innovation, it means that we do the same thing every day. Literally. We consume the same basket of goods. Right? We produce the same thing, we work the same hour, we just do the same thing. Because as soon as I start doing something different at the shop, I'm innovating. I'll put a table out that I didn't yesterday, I cook a different sandwich, I don't know. Right? That's an economic innovation. Who cares if it is, not everybody's always inventing penicillin. Sometimes they invent, I don't know, burrata, or whatever, tramezzino, right? Spritz, that's an economic innovation too. You can make a lot of money out of spritz, right? Good. So that's his point. You know, Schumpeter was a brilliant man that knew a lot of facts and history, but was remarkably sharp as a theorist. He said, so let's try to think of what a stationary world is. He said, it's never kind of existed, really, but more or less we can approximate it by thinking rural communities, old societies where there is